Dear students, today I'll discuss with you some important points on the chapter Chemical Energetics. First point, if the reaction takes place at constant volume, then according to Kirchhoff's law, delta E2 minus delta E1 by T2 minus T1 is equal to delta Cv. What is Cv? Delta Cv is the difference in heat capacity of products and reactants at constant volume. Okay? So this is your internal energy, this is your temperature. Okay. Then second point, what is delta Cp? This is delta Cp, this is delta Cp. What is delta Cp? Specific heat capacity at constant pressure. Okay, heat capacity at constant pressure. Okay students, so instead of here delta E internal energy, you will take here delta H2 minus delta H1 by T2 minus T1. Okay. Then point 3. The last video I explained, I will solve a problem based on Kirchhoff's law. So this is the problem. Problem based on Kirchhoff's law for a reaction 2A to B gaseous state, the heat capacity or CPA, this is 10 joule per Kelvin, and this is CPB 20 joule Kelvin. Okay, given delta H at 300 K is delta has 300. Calculate the difference in enthalpy, that is delta has 600 to delta has 300 if the temperature increases to 600 Kelvin. So this temperature rises. Okay, this temperature rises 300 to 600. Okay, you should not confuse. Okay, so you put the what are the things given. So delta Cp is equal to delta Cpb minus delta Cpa. This is 20 minus 2. This is 2a, na? This is 2a. So 2 multiplied 10. So 20 minus 2 multiplied 10. This is also 20 is equal to 0. And delta has 600 minus delta has 300 is equal to delta Cp delta T. Delta T is 300 and delta Cp is 0. So therefore your total is 0. That is the enthalpy change remains the same because of delta Cp is 0. Okay. So this problem is based on the Kirchhoff's law. Another problem I will explain. For a reaction 2A to B, if CPA 20 joule per Kelvin and CPB 60 joule per Kelvin, the difference between the change in enthalpy at two different temperatures, delta H2 minus delta H1, is 80 joule. Find the change in temperature, that is delta G we have to find. So delta Cp is equal to Cpb minus Cpa, 60 minus 2 multiplied 20, this is 20 joule. Okay. So delta T is equal to delta H2 minus delta H1 by delta Cp. So this is your 80 given 80 and this is 20. So you are getting 4. So delta T is 4 Kelvin. Okay students. Next point. For point 5, for isothermal expansion, delta E is equal to 0, delta T is 0. Work done W is equal to minus 2.303 nRT log V2 by V1. So these relations you have to remember for problem solving. So here why isothermal expansion, you know isothermal means temperature remaining constant, but temperature delta T is 0. But why delta E is 0? Because delta E, that is internal energy, is depends on the temperature. Okay. So kinetic energy, internal energy, they are depending on the temperature. Therefore delta E is also 0. So V volume is inversely proportional to pressure. Therefore if you put pressure, then it will be P1 by P2. Okay. Yes. So heat absorbed Q is equal to minus work done. Sixth point. For adiabatic irreversible expansion, since Q is 0, adiabatic means Q remains constant. Okay, so if Q is 0, work done minus W is equal to minus del E. So minus del E means minus CV delta T, that is expansion, P expansion and delta V. So minus work done is equal to NR T1 minus T2 by gamma minus 1. Okay, what is gamma? Gamma is Cp by Cv, we know. So this is nRT. Okay, nRT, you put minus, so you will get T2 minus T1. So it will convert, gamma minus 1 will convert to 1 minus gamma. Okay, and you understand? Where gamma is Cp by Cv, so gamma minus 1 you will get R by Cb, because Cp minus Cv is equal to R. Okay, Cp minus Cv is equal to R, we know. Okay, yes. So work is done at the expense of its own internal energy, indicating by cooling effect. Okay, you read this line carefully. Work is done at the expense of its own internal energy, indicating by cooling effect, that is T2 is less than T1. So internal energy decreases. Second, next point. In adiabatic irreversible compression, it is given irreversible expansion. In both the cases, adiabatic means this Q remains 0. Okay, so in adiabatic irreversible compression, it is also Q0. So heating effect is observed, that is T2 is greater than T1, and work done on the system, so work is positive and del E is positive. So internal energy increases, that is work done is equal to R T1 minus T2 by gamma minus 1. Okay, yes. For an ideal gas undergoing adiabatic reversible expansion or compression, we know P1 V1 the power gamma is equal to P2 V to the power gamma. What is gamma? Gamma is Cp by Cv. So Pb the power gamma is a constant value. So or you can write Tv gamma minus 1 is a constant. So these are the relations for the examination. Okay, and Tp 1 minus gamma by gamma is also a constant. So these points you have to remember. Next, so gamma is Cp by Cb. It depends on what? Cp by Cb or gamma depends on what? It depends on degrees of freedom of gaseous molecules. Okay, these are depending on the gaseous molecules. We already discussed what are the values of monoatomic, diatomic gases, the degree of freedom, Cp by Cb value. Okay, but still I will explain in the next video. Okay students, have a good day.